In today's lecture, I'd like to talk about annuities and gradients that are deferred in time. This is an example of a non-standard annuity and gradient, and one that occurs quite frequently. Here's a diagram of a standard annuity, this one 6 periods in length. And I'd like you to compare it to the one below of a displaced annuity. You can see the number of periods of payment are the same. The compounding period and the payment period are the same. But what's different in the displaced annuity is that the first payment doesn't occur at the end of the first year, as in the standard annuity. It's been displaced in time. This one's been displaced 4 years in time. But of course, that displacement could be arbitrary. And it could, of course, be in the past as well. And in particular, for example, an annuity due is a special case of a displaced annuity where it's been displaced one period in the past. But displaced annuities or gradients could be arbitrarily displaced. Here's an example of a problem involving a displaced gradient in this case. A new software package is expected to improve productivity at Waterloo Insurance. However, because of training and implementation costs, savings are not expected to occur until the third year of operation. At this time, savings of $10,000 are expected, increasing by $1,000 per year for the following 5 years. After this time, 8 years of implementation, the software will be abandoned with no scrap value. How much is the software worth today at 15% interest? Now, this is a somewhat contrived example because, of course, although gradients do exist in the real world, they're often bound up with other more complicating payment patterns as well. And I just wanted to create a problem that had a simple gradient. But it's not really atypical, the kind of problems you can see in real life, where you have savings occurring at some point in the future, and those savings increasing over time. What we want is how much the software is worth today, so that's a present worth. And clearly we're given an annuity, or a gradient here. In fact, here's a diagram showing the pattern of the payments. Our first payment occurs at the end of the third year of $10,000, and that increases by $1,000 each year thereafter until the end of the 8th year. This fits the pattern of a standard annuity, except that it's been displaced in time. It's been displaced, in fact, 2 years, because you recall the first payment of a gradient occurs at the end of the first year. The increasing of amounts by G each time occur at the end of the second year. So it's been displaced 2 years. The way of dealing with this problem is exactly the same as with all displaced annuities and gradients. It is just simply taking a point of view and putting it at the point in time where the gradient or annuity conforms with the standard. So in this case, if we put our point of view at the end of year 2, and if you like, consider that to be year 0. So that would be 0, 1, 2, 3, 4, 5, 6. That becomes a standard gradient, not displaced one, a standard gradient, 6 periods in length. And if we find a present worth of that gradient, that would be a present worth at year 2. We can take that present worth at year 2 and move it to a present worth at year 0. That's the procedure we'd follow. And in general, we'd calculate whatever we need to from a displaced annuity or gradient, and then interpret that resulting calculation with respect to the desired one. So we might convert this to a future worth, to an annuity, to anything we want, and subsequently take that displaced value and use it in whatever way is necessary to calculate the value that's desired. So in this particular case, the first thing we want to do is to calculate a present worth of this gradient at the end of year 2, which we can interpret as being the year 0 for that calculation. So we've got the $10,000 base annuity plus the gradient part converted to an annuity at the 15% interest over 6 periods. because our point of view is now at the end of year 2. Now, that's an annuity. We want to convert that annuity to a present worth, because we're looking for the present worth, by multiplying by the series present worth factor at 15%, and still for 6 periods. Right? So this entire expression now gives us a present worth at the end of year 2. To find the present worth today, that's moving that present worth at the end of year 2, considering it as a future worth now, and taking it back in time 2 years. So although this was considered to be a present worth when calculating the equivalent value for the gradient, it's considered a future worth when calculating the present worth today, because that amount is 2 years in the future if we take our perspective back to today. So that value here, the result of that calculation, must be multiplied by the present worth factor, where that future worth was what we calculated as present worth before, at the 15% interest, in this case over 2 years, because that was 2 years in the future. So we end up with one long expression here, but it comes about through a natural logical process of taking our point of view at the end of year 2 first of all, recognizing it's a standard gradient, finding the present worth from that perspective, then recognizing that present worth at the end of year 2 is a future worth from the point of view of year 0, and finding equivalent present worth for that future worth. That can all be done in one expression like this one. It looks complicated when you look at it just by itself, but when you build it up sort of step by step, as you just did, it makes a lot of sense. If we work through that calculation, looking up the values for these compound interest factors, it works out to be $34,616. The software is worth that much today, and you could use that amount, for example, to determine how much we paid for it. So with deferred annuities and gradients, the idea is really quite simple. It's just a matter of taking your perspective to different points in time, using your standard formulas for those points in time, and then taking the value of applying the standard formulas and reinterpreting them to calculate whatever it is you desire. So in this case, we calculated a present worth under one perspective, but in a different perspective, that present worth was considered a future worth. So what we've got to do is become flexible in your mind as to how to interpret these different payment patterns in terms of these standard definitions of annuities and gradients. Thank you.